So here in this problem, we are provided with 4 different sequences. We need to show that each of the sequences are in AP, that means they are in arithmetic progression. And also, we need to find out the common difference in each of them and write 3 more terms. Fine, so let's begin with our first one. So in the first problem, we are given the sequence 3, -1, -5, -9, and this goes on. So let's try out by finding the common difference. So the common difference can be obtained by, we can consider any term on the sequence. So we'll consider the second term, which is -1, and from it we have to subtract the previous term, which is 3. So -1 minus 3, so this is going to give us -4. Now we need to actually check that this particular sequence is actually in AP. So for this, we are going to do is consider the third term, which is -5, and from here we have to subtract the second term, which is the previous term. So we'll have negative of -1. So this is also going to give us -4. Similarly, we can check out with the fourth term, which is -9, and from it we are going to subtract the previous term, that will be the third term. So -9 minus -5, and this is also going to give us -4. So here we see that in each of the 3 cases, our common difference is exactly the same. Then we can say that our given sequence, so one is in AP. So it is following an arithmetic progression. Now because it is following the arithmetic progression, then all we have to do to find out the 5th, 6th, and the 7th term. So to find out the 5th term, all we have to do is take the previous term, which is A4, and to it we are going to add the common difference. So our common difference is -4, so our fourth term is -9. So to it we are going to add -4, so that means our fifth term will be -13. Fine. To find out the 6th term, we take the previous term, that is A5, and to it we are going to add the common difference. So this is going to give us -13 plus the common difference is -4, so this is going to be -17. Then A7, so this is going to be A6 plus the common difference. So the previous term A6 is 17, -17 minus 4, so this is going to give us -21. Fine. So how many terms? We need to find out 3 more terms. Fine. So this is A5, A6, and A7. These are the 3 terms for the given arithmetic progression. Fine. So now we will start with number 2. So let's begin. So here we note down the corresponding first term. So this is going to be a first term, -1, which is A1. 1/4, this is going to be a second term. 3/2, this is our third term, and 11/4, this is our fourth term. First, we will obtain the common difference. So our common difference can be obtained by taking the second term and from it subtracting the first term. So this must be equals to taking the third term and from it subtracting the second term, or similar, taking the fourth term and from it subtracting the third term. So let's find out the value in each of the case. Our second term is 1/4 minus the first term is -1. So this is going to give us 1/4 plus 1, which is simply 5/4. So let's find out the common difference, A3 minus A2. So our A3 value is 3/2 minus 1/4. So this will be equals to, so we'll make the denominator of the first term 4, so that we are going to multiply both numerator and the denominator with 2. So that means we have 6/4 minus 1/4. So this is also giving us the value 5/4. Fine. And finally A4 minus A3. So A4 is 11/4 minus A3, which is 3/2. This will be equals to 11/4 minus 6/4, or simply 5/4. So here we have seen that in each of the cases we have obtained a common difference of 5/4. So we can say that number 2, so our sequence given by number 2 is in AP. So that means it's following an arithmetic progression. Now we have to find out the 5th, 6th, and the 7th term. So A5, so this will be simply equals to, we'll take the 4th term in the sequence, and to it we are going to add the common difference, which is 5/4. Now A4 value is 11/4. To it we are going to add 5/4, and this is going to give us 16/4, and 16/4, that's simply 4. So this is our 5th term. Now we'll go to the 6th term. So 6th term will be, we'll take the 5th term, and to it we are going to add the common difference, which is 5/4. And this will be equals to 4 added to 5 over 4. So this will be 21 over 4. Right. So this is our 6th term, and our 7th term will be the 6th term. Added to it is the common difference, which is 5 over 4. So 21 over 4 plus 5 over 4. So this is going to give us 26 over 4, or simply 13 over 2. So this is going to be our 7th term, and we can finally say that our final sequence will be -1, 1 quarter, 3 2, 11 quarters, and the 5th term is 4, followed by 21 quarters, and the final term is 13 over 2. Coming to part 3, so we will find out the common difference. So our common difference will be, we'll consider the 2nd term, and from it we are going to subtract the 1st term. So this is our 1st term given by square root of 2. Our 2nd term is 3 times square root of 2. The 3rd term is 5 times square root of 2, and our 4th term is 7 times square root of 2. Fine. So a2 minus a1, we'll find the value. We have 3 times square root of 2 minus a1, which is square root of 2. So this will be equals to 2 times square root of 2. Similarly, we'll find out the common difference by subtracting the 2nd term from the 3rd term. So our 3rd term is 5 times square root of 2 minus the 2nd term, which is 3 times square root of 2. So this is also going to give us 2 times square root of 2. And finally, we have the 4th term, and from it we are going to subtract the 3rd term. So this is 7 square root of 2 minus 5 square root of 2, and this is going to give us 2 times square root of 2. And therefore we can say that 3, the sequence given by 3 is in arithmetic progression. Fine. So let's find out the 5th term. So a 5th term will be, we'll take the 4th term, and to it we are going to add the common difference. So our 4th term is 7 times square root of 2 plus the common difference, which is 2 times square root of 2. This is going to be 9 times square root of 2. The 6th term will be, consider the 5th term, and to it add the common difference. So this is going to be 9 times square root of 2 plus 2 times square root of 2. That's going to give us 11 times square root of 2. And the last term, or the 7th term, will be the 6th term added to the common difference, which will be 11 times square root of 2 plus 2 times square root of 2, which is 13 times square root of 2. Therefore, the number in the sequence are square root of 2, comma 3 times square root of 2, comma 5 times square root of 2, comma 7 times square root of 2, comma 9 times square root of 2, comma 11 times square root of 2, and the final term is 13 times square root of 2. So these are the numbers that are in arithmetic progression. Let's move on to the 4th and the final problem. So here we have the given sequence. 9 is our 1st term, 7 is our 2nd term, 5 is our 3rd term, and 3 is our 4th term. To find out the common difference, this will be equals to the 2nd term minus the 1st term, which will be equals to 7 minus 9, that will be -2. Then we can also find out the common difference by considering the 3rd term, and from it subtracting the 2nd term. So we have 5 minus 9, 5 minus 7, not 9, that's -2. And common difference can be also obtained by subtracting the 3rd term from the 4th term. That means a4 minus a3. So a4 is 3 and a3 is 5. So 3 minus 5 will be -2. So since we have found the common difference of -2, we can say that this is an arithmetic progression. Fine. Now we will find out the 5th term. So to find out the 5th term, we consider the 4th term, and to it we are going to add the common difference. So our 4th term is given as 3. So we have 3. To it we are going to add -2. So this is going to give us 1. The 6th term of the sequence is going to be the 5th term added to the common difference, which is going to be 1 added to -2. So this was going to be -1. Then we have the 7th term, which will be the 6th term added to the common difference. So our 6th term is -7, and to it we are going to add -2. So this is going to give us -3. So therefore, our complete arithmetic progression will be 9, 7, 5, 3, 1, -1, -3. So these are the numbers in the given sequence and they are in AP.